Welcome to Temple of Pwn, Part 9. Today we're just going to talk about Ret2CSU, and it's just something pretty simple that you can use in ROP chains to kind of get what you're looking for in an exploit when you're missing some gadgets. So here's the main theory behind the Ret2CSU is the function itself, libc CSU init, which is called pretty much every time in an elf binary at the beginning. It's usually one of the first things. It helps set up the initialization of any kind of linking, I'm pretty sure, and that kind of stuff. Yeah, it's one of the first functions called. It gives a ROP gadget. Right here you can see it gives pop RBX, RBP, R12, 13, 14, 15, which that doesn't really seem useful at all. But if you look up here, it does a move RDX, RSI, and RDI, the registers we just used, and then calls base of R15. So if you're able to control the stack and can get over here, and you're able to control R12, 13, 14, 15, and RBX and RBP, because it will do some looping stuff, then you'll be able to pretty much just get an arbitrary kind of first three parameters for everything. And usually this is kind of where the hardest parts sometimes with ROP chains is trying to figure out how to control RDX, where if you are able to just get back here, you can now control RDX. So if you have a exec VE or something, you're able to get 0 in there, or if you want to read a certain amount of bytes or write, then you can just keep going from there. That was kind of the only slide I have because that's kind of all there is to it. So I'll kind of show off an example from, this is called ret-of-the-rops. It's from the 0x41414141 CTF, which started last week and is technically still going on today, but ends tomorrow morning or something. When this video goes out on YouTube, it'll be over, so we don't have to really worry too much about it. But the main thing here is that it will set the buffer. Don't worry about that. It does a gets printf on your buffer, and then it's just a leave ret, as they usually are. And so with this, technically since we have a gets and printf, we don't really need the ret2CSU to really get an exploit fully, but in case just for this kind of scenario, we're going to do it. So as we saw that, start up, move exploit to back.py. Just get our stuff going. Ret-of-the-rops. Let's do a gdb.attach. So first we need to figure out how much buffer we need to send in to actually start doing a ROP. So we can do cyclic and just create 100 characters. Go back in, do a p.sendLine. Continue, see that we end at KAA. Cyclic. See what to send in 40 characters. Before we can start working on a chain of some sorts. So now we just pretty much need to create a chain, and that's kind of all there is to it. Since the challenge itself is using printf, do we want to use this printf to leak the libc address, or do we want to use other methods to actually leak it?
I vote printf.
Okay. So that should be too bad. We probably just change these. Let's probably do that first before we get this chain and stuff set up. Do just %p time. Let's go 30. We can look to see what we're working with. I think these are both libc addresses, which they look like it. It's probably just from the first time printf is called. So we could possibly use those two, but I think it's safer if we just used libc ret right here, I think. Nope. Is this one libc ret? Maybe I overwrote it. I definitely probably overwrote it because of... That's actually stack. What am I thinking? Probably definitely overrode because all these print out. Yeah. So let's see, if, let's do some quick math. If 40 characters is overwriting, then we would need to do percent 40, that's 28, I think. No, plus 6, 14. Do a quick check. Usually the first 6 come from the registers, so then we go 7, 8, 9, 10, 11, 12. It's 12. Almost.
I'm gonna go help Mason.
Sounds good. So we have 12. We can get the leak from that. Which looks not correct still. I don't think. Yeah, we're definitely off by still 1, it looks like. So 11. Okay, so ignore my thing about the 5 and 6 or whatever.
Done.
Yep, PETA will read until 0x. We don't really have a good way to stop this, but there's a good chance it'll always be 6 hex characters, so 12 characters overall. You just convert that to an int. So that should be our leak. So let's just work on our chain now. So what we need is, we already have our 2 gadgets, we just need to know what their address are, and if we look back over here and libc.csu init, the address would be for the actual calling of CSU, it'll be 401240, and then the gadgets would be 40125A. Keep that open for now. We'll call CSU underscore call 0x401240. CSU underscore call the ret 0x4012.5a. Next, since we already have a leak, we don't really need the to leak from the got or something, so we can probably just use puts underscore got and overwrite that with system. And that will be at this address, and then we'll also need the gets got to call gets, so we can overwrite it. I think that should be all we need. So first we're going to do a CSU underscore ret, then we need to do our gadgets, which I'm going to write just right here so we don't have to look back at it. RBX, RBP, R12, 13, 14, 15. So RBX we're going to want to be at 0 because it uses that for the offset when we actually call a function 2. RBP it uses as a counter in this case, so that it'll compare RBX to RBP to see if we should exit our loop. We want this to be 1, so when we increment RBX we actually don't call or go through the calling function again, because it would probably call printf in that case, which isn't really a problem, but it's just not what we want. R12 can be 0, R13 can be 0, because those would be RDI would be R12. So we want that one to be the puts got address. R13 can be 0 and R14 can be 0, because those would be our DX and our SI, and when we overwrite the puts got by calling gets, that doesn't really matter. And R15 we want to be the get got. Fix that to gets. So then it'll return, and we want to return to CSU underscore call. From there, it'll actually go through the thing again. We'll put a first 0 in there because of the add RSP8 after it exits the loop. And then we have to go through this list pretty much again. 0, 1, R12 will be, we'll go puts got plus 8. I'll show you one a little bit. 0, 0. R15 we'll put to puts got, because we're going to overwrite puts got with system. Then I think just another CSU call should do it, honestly. chain is equal to join map p64 of chain. So we do this plus this will be 2, 4, 5 characters. So we need to add 35 A's. Get the chain in there. Get the leak just to see if it actually is reading it correctly. I think that should do it for now. Let me just kill this one. Probably the last one had. There we go. So we go to the printf. Did not read it the way I wanted to, so it looked like it for some reason is different now. Cool. Why would that change all of a sudden? Oh, because I'm overwriting it. That would make sense. Okay, so we had to find a different address besides libc ret. And I guess we could use this one, which looks like a libc address. F8C0, F8... Ooh, it's actually after. Okay, so we are not going to go with a writing of this because, or reading from the stack, because it is not going to work the way we want it to. I mean, it's still possible because we could read that address and there's a good chance that the offsets are still static, but depending on the remote version libc, if you're doing this challenge remotely, it probably won't work as nicely as getting something that'll always work, such as printing from the GOT. So let's try that instead. So go 0, 1, puts underscore GOT, 0, 0, puts underscore GOT, CSU underscore call. I think I'm going to just get rid of this one and put a 0 there, and I think that should be the same. So let's follow through this. Go to the ret, RBX, RBP, R12, which would be RDI, RDX, or RSI, RDX. Puts GOT will be put into R15, which it calls it through dereferencing the value. So this will call puts on puts. And then the CSU call. So that should work. We'll just need to change the way we're leaking also. So we probably want to read until the first new line, and then I'm going to do it a way I don't like to do it, but I think it's one of our only options, just to read the line and then take the last 6 characters of that line, because it's also going to print out all this stuff since our printf doesn't have a new line in it, and that's going to be really gross. And we can't send a new line into print because for some reason \n doesn't work when it should. I thought it would, but when I was testing earlier it wouldn't. Maybe I was just messing up, and if we just send in a new line, then the gets will break because our chain won't get sent fully then. But I think this should work if I can finish the line correctly. Check to make sure. I don't think I ever... Gotta make sure it reads. That won't work, and neither would this. For those... I wonder if this new line's stopping it too. Weak. Oh, yeah, right here. Which that looks semi-correct. Maybe not. So now the question is, what did it actually leak right here? We have a 3F79, 617F20, 6F. That just looks like straight ASCII to me. So there must be a, let's just check to, without reading those so we can see what's actually printing out right away. And yeah, that must have been this stuff then. So first we need to read to the, I guess we don't need to read to the new line if we just print or send after that new line. Question mark new line. Now there's a good chance this should be closer to our target. Oops. But maybe not. Oh, it's not gonna give us interaction control because we haven't done the puts yet, so it's not printing a new line. That makes sense. Okay, so inside our chain we do pop RBX, RBP, R12, 13, 14, 15, ret, RDX, RDI, and RDI. So we just check real quick. So R15 points to puts. Increase this a little bit in case you guys can't see. Our DI points to puts also. The other registers don't really matter in this case. Next instruction, and that's the leak we're looking for. Yeah. So we can just find the offsets. This one. Just need to. I really don't want to do it by hand. But oh well. We do 0x7f 9d 471590 minus the libc address to find out I typed it wrong or something. Okay, I'm just gonna do it the good old way and unpack it first. Puts. Guess we could have checked to make sure the other addresses or the rest of the chain was correct, but YOLO. We don't actually care about that, so we care about system. Does that work? Nope. So it looks like we just need to take puts minus this address, and that should get a system. System minus or equals puts minus this value. And then we do a p.send line of p64 system, because hopefully our gets down here writes into puts. And then we're also going to do a write bin sh to the address right after or puts, which would be system. So this way we have, oh darn, I didn't want to close it. This way we have bin sh in its location that we know, which would be puts plus 8, and when puts, which would be system at this point, gets called, we should have hopefully a shell. Printf, go through this, do a puts call here, get our leak. Did the compare if RBP, RBX, that's why we incremented RBP 1 more than RBX. RBX 0, RBP 1, R12, 13, 14, 15. Should point to gets, yep, ret, call gets. And check our got, that looks like a different address. Find out if it's correct. And it definitely doesn't look right, but it doesn't look like puts either. Yeah, my must have subtracted incorrectly. Or gotten the wrong offset. Minus this address. Yeah, those are way different. Oh well. Well, let's just continue to make sure everything else looks right. So if we go down to the last one where this would hopefully be system, it's right now some weird function. Looks like RDI points to bin sh, RSI, and RDX don't really matter still, but everything does look right if we can get the correct offset. And we should be able to just continue and see that we got the shell correctly. So this was kind of just a real quick and dirty Ret2CSU. This challenge is kind of a poor example of how it's powerful, and the main reason this would be used is if you're trying to, a lot of times this might be read or write instead of gets and printf or puts, and in that case there's a lot of times where when you get to the end of the function you have a ROP chain going, you don't actually control RDX, and that can be really problemsome if you don't have enough bytes to, if RDX is 0 and you want to write out a leak, you don't really have anything to go with. But this way you're able to actually overwrite RDX and get a leak going, or just any kind of more chain from there. So yeah, are there any questions? Even though there's not really much to it, I don't think.
No, that was good.
Alright, perfect.